This is kind of talking about some of the memory acquisition considerations we talked about yesterday. The fact that they do need to load a driver, or that there are differences between different architectures, 32-bit, 64-bit systems. Be aware of the footprint that you're going to make by that by running the application. That you may have to, having multiple vantage points for memory can be beneficial as well. So having two different sources, whether it be physical memory and debug memory, can give you kind of two different perspectives from the system and things like that. So here's kind of a similar slide, but with a little bit kind of more refined. Some of the tools that are out there. So we talked about WinDD and kind of some of the Windows memory imaging tools. I want to point out some of the Linux tools that are out there. FMEM, for example, I talked about quickly yesterday. There's also Second Look, which is very similar. Second Look, I think, is a paid tool developed by Pikeworks, which is now owned by Raytheon. And then, excuse me, you also have DD, which doesn't really work anymore on modern Linux operating systems because of how it handles access to memory to the devmem device. And then for OS X, you have the Mac Memory Reader, which is a freely available tool from ATC New York. And that'll allow you to image Mac memory. And they also have an analysis tool, which is a paid tool. Yeah.
If I don't ask now, I'll never get.
No problem.
On chart number 14, it says physical memory versus debug memory. What is the
you're talking about slide
memory?
Back?
So
debug memory would be like kernel debug memory, which would basically be like, so the kernel will perform, it's kind of similar to a crash dump in a sense, where it's basically containing things that the kernel uses, or things that the kernel provides to the user so that they can perform debugging of a system. So things like what was loaded into the kernel, what symbols are being called, and things like that, so that it can use.
Nevertheless, they are part of the physical memory, right? They are
I'm sorry?
They are all in the RAM.
You're asking, are they? It's in physical memory as well.
Right.
It is. It can be harder to access through physical memory analysis, right? Not saying that it's impossible, but sometimes the presentation from two different vantage points will make it a little bit clearer, as well as it's taking it from two different perspectives, right? The kernel, when you're doing a kernel debug or you're doing a dump from that perspective, is taking it so through the kernel, through the operating system's interaction with the kernel. The other mechanism is using like an external application, a third-party application that's loading a driver and so on and so forth.
Okay, thank you.
Mm-hmm. So some of the kind of the analysis tools, now we're going to kind of get more into that, is some of the things to consider is kind of the variance between different operating systems. This becomes kind of important when you're dealing with things like different variants in Windows. The way that they kind of allocate memory and handle memory and their structures are all a little bit different. Some of the times you are going to have size consideration issues. So kind of some of the smaller items aren't so much of an issue, but as you get to bigger data sets, 32, 64, 128 gigabytes of RAM, those can cause some problems from an analysis perspective, or at least slow the analysis. And then you also kind of need to be aware of the fact that some data that from memory may have been written out to the page file. There are mechanisms of doing kind of a connection between the two, a little bit outside of the scope of this class, but just to kind of be aware of that. Some of the analysis tools that are out there, we're going to focus on volatility at the top, but we're also going to talk about Mandiant's Redline. But there are other ones that are out there. FTK has the capability of doing memory analysis. There's now FTK4. These slides are a little bit old. That came out recently, so I have no experience with it. It's okay, right, at doing memory analysis, so I encourage you to kind of give that a shot. KNT Tools and KNT List, which is from George Gardner, who also developed KNT DD. Those are paid tools, but they work really well. He's done a really good job of kind of interpreting structures really well. There's PT Finder, a pool finder developed by Andreas Schuster. WinDebug, which is, for those of you that want to use it and feel comfortable using it, I totally encourage you to do it. I find it to be incredibly difficult. There's one of the benefits of WinDebug, as I pointed out yesterday, though, is that it can interpret any, like if you perform a dump in a Windows crash dump format, WinDebug can interpret any operating system, any processor architecture that you can install Windows on. So that's kind of important. So if it's something that you're stuck and you can't find another tool to interpret your memory image, WinDebug will be able to handle it. As long as it's Windows, of course. If it's a Linux memory image, it probably wouldn't do too well. HB Gary has their tools as well, and then Ncase has some processing as well. I can't really speak too much to their capabilities.